Okay, so this is the benefit cost ratio example for you guys will have for homework 5, what we went over in class on Friday. So sorry this came up a little late. First, as always, let's read through them. So your agency is looking at 2 thinning opportunities to mitigate potential fire risk. Option 1 will cost $2,500 an acre and must be repeated every 12 years to maintain a 27 mile per hour torching index. So pause there. Torching index is the 20-foot wind speed in miles per hour, so that's 20 feet in the canopy, at which a surface fire is expected to ignite the crown layer. So a higher number there means that it's going to take more wind for that fire to get from down on the ground to up into the canopy, and I'm assuming we don't want that. Okay, option 2 costs $6,000 an acre and must be repeated every 16 years to maintain a 41 mile per hour torching index. Current torching index we have is 5 miles per hour, so not so good, pretty low wind, and you could have a fire get up there into the crown. These thinnings are going to take place in the 5th year. So, right, it's going to take a little time to put the program together, go through EIS, NEPA, whatever it is we have to do. We've been directed to use a 6% discount rate, and that we should look at these thinnings as going on forever. So we're going to look at them perpetually. And so what I did here is I took this information from the word problem and put it down into a form that I could look at, where I got my discount rate, I got the initial torching index, I have an option 1 cost of $2,500 per acre, option 2 cost of $6,000 per acre. Torching index after that thin in option 1 is 27 or 41 after option 2. And the first thinning is going to take 5 years from now. It's going to take place, and then these are the intervals that we have for the 2. So this is a benefit cost ratio. So if you're looking at your homework there, right, you'd see we're going to put benefits over costs, and that's basically what we want to do. So first, let's look at benefits. Okay, so in this case, it's not going to be dollars that are the benefits. It's going to be this wind speed. So the whole reason that we're doing this is to generate additional, I guess, buffer in terms of the wind speed it would take to get a fire from the ground up into the crown. And so we want to know what that benefit might look like. Right? We've got to do a timeline because it's going to be looking out over time. And what we have here is 1, 2, 3, 4, 5. Okay, and then we thin it, and then we have 6, 7, 8, 9, 10. So the thin happens here. So for those first years, I'm going to have a 5 mile an hour wind speed. For those 5 years, then I thin it. I have a cost here of minus 2,500, and now I have 27 mile an hour wind speeds. 27, 27, that looks like a 2, 27, 27, 27. So timeline looks like that. Out here in the future, 12 years after, so at year 17, I'm going to have another 250 or 2,500, and on and on and on. So that's going to go on. This annual wind speed is going to be maintained at 27 miles per hour. So for the benefits, what I'm looking at here is a terminating annual for part 1. So let's do that. Terminating annual. And when I go look at my handy dandy sheet, I see that it's a series, it's annual, not every n years, goes on for, this one ends in 10 years, terminating, ends in 5 years, and I want the present value, so it's this one here. So if I'm writing that out, I'm going to do my VO equals A 1 plus I to the t minus 1 over O point, or let's put an I there, times 1 plus I to the t. So it looks like that, where I know that my a, in this case, are these 5s. My t is 5 years that it's going over, and my I is 6% that I had up here. And so I can do that with it plugged in at 1.06 to the 5 minus 1 over 0.06, 1.06 to the 5. And if I did that right, I'm going to get 2106 miles per hour wind speed. So that's these first 5. Now, from here on out, I have 27s that go on and on and on forever. So, whereas we looked here with it ending in t years and got the present value, this one, we're going to use this one here, where it's a present value that goes on and on and on. Okay, and so this is the perpetual annual. And in that case, it's VO equals A over I, with our A is going to be the 27 miles per hour, and our I is 6%. Let's put a little there. So if we plug into that, we have 27 over 0.06, which, if we did it right, should be 450. So, but now we look at where this 450 occurs. So if we're looking at the series of these annual payments, they start here. So what I have to do then is take this 450 and move it from here to here, or discount it 5 years. So if I put that over 1.06 to the 5, I will get 336.27 miles per hour. So that we have there. Those are our benefits. Now we want to look at costs. And in this case, we've got these ones going here. So my cost one, if I'm looking at it, has N, 2N, 3N, and I'm going to get a VO and these A's. So it is the perpetual periodic that we've been dealing with. VO equals A over 1 plus I to the N minus 1. Right, so that's just down in here. It's a payment every N years, goes on forever. So that was where I got that from. And my A is, in this case, the $2,500 that I'm going to spend. The N is that I'm going to spend it every 12 years. And the I is 6%. So if I plug that in there, I'm going to get 2,500 over 1.06 to the 12 minus 1, right? But if I do that, this 1.06, right, that puts me here. But I'm looking at an A that happens every 12 years, so 12, 24, 36. I am standing 5 years from there at year 7. So that's me with my first inning, get 4 legs there, is going to happen in 5 years. So when I solve this equation with all of these A's, with that one every 12 years starting 5 years from now, it solves it back here. And so I have to take it and multiply it by 1.06 to the 7. And that takes this value here and brings it to where I'm standing currently. And if I do that, I should get 3713.78. Okay, so that's present value of all the costs. So to do my benefit cost ratio, let's block a little thing off here, BCR. I'm going to put the benefits which is 2106, the first 5 years, plus 336.27 over the costs of 3713.78, or my BCR equals 0.096 miles per hour per dollar spent. Right? These are miles per hour, that's dollars. So benefit cost ratio of this first one, 0.096. Okay, so that's the first part. Second part is we want to compare this thing that we have going every so many years. And so I have to do a part 2 here. Okay, what's option 2? So in economics, we're almost always looking at trade-offs or choosing between alternatives, right, and allocating scarce resources, dollars in this case, to benefit the natural resource that we have. So if I move on to part 2, here, if I look at that timeline, 1, 2, 3, 4, 5, these are 5, 5, 5, 5, 5, and then in this case, I come in and it's a 41 mile per hour, 41, 41, 41, right? 5, 4, 3, 2, 1, 0, 6, 7, 8. So the 41 goes on and on and on and on. So part 1 of the costs, or sorry, these are the benefits, is going to be the first 5 years of these 5 miles per hour. Now, we know from doing it before what that answer is, right? It's the same. In either case, it's the same timeline, in the beginning. And so I know that part 1, the first 5 years, equals 2106. Right? And part 2 is going to be the perpetual starting in 5 years. And so just like before, that's a VO equals A over I, with the A in this case being these 41s, and the I's being, or sorry, the I is always 0.06, 6% that we're looking at. And just like before, I need to move it after that. So I'm going to go 1.06 divided by, remember we divided by 1.06 to the 5. And that gets me crunched and slid all in one movement there. And that answer is 510.63. So same steps that I did before, where this one I did it in 2 steps. Here I'm just going to do it all at once and get my 510. These are miles per hour and miles per hour. Now I'm on to cost. And so just like before, I'm going to have a cost where I have where I am. So I'll do this maybe just a little different here, in that I have 5 years from now, I'm going to have my payment of 6,000, and then every 16 years it's going to happen. So at 21 and 37, I'm going to have minus 6,000, minus 6,000. And so the beginning of this thing, right, that's me at year 0. The beginning of this thing is 16 years back. So 5 and minus 11 would be kind of the VO that this equation, this perpetual periodic equation, would solve at. VO equals A over 1 plus I to the n minus 1. So I'm going to want to take the value that I get there and slide it forward or compound it 11 years. And so how I'm going to do that is take my VO equals my A, which is the negative 6,000, over 1.06 to the 16. There's 16 years in between them, minus 1, and I'm going to multiply that by 1.06 to the 11. So crunched all of these values into a single value here, and then sliding it forward 11 years that way. And if I do that, I should get $7,394.20 as a cost. So I'll drop the minus because I'm going to call that a cost. My benefit cost ratio is going to be the benefits, 2106 plus 51063 over the cost, 7,394.20. And if I did that right, I should get 0.072 miles per hour per dollar spent. And so in this case, if I was looking at these, in option 1, for every dollar I spend, I improve the wind speed, right, by 0.09 miles per hour. Whereas in option 2, for every dollar I spend, I improve the wind speed 0.072. So because a higher wind speed is what we want it to take more wind to get that up into the crown, I would choose option 1 because I got more bang for my buck in looking at this. So hope that helps you, and I'll see you in class.